I'm Emily Calandrelli, and today you'll be following me behind the gates on this exclusive bus tour of Kennedy Space Center. Our journey will take us past active facilities and end at the visitor complex's own Apollo Saturn V Center.
But before we begin this journey, just like every NASA mission, our #1 goal is to return home safely. So always stay seated while the bus is in motion. Please, no food or drinks on the bus with the exception of water. Please keep conversation to a minimum so others may hear and enjoy the tour.
Smiling, one more.
No photography is permitted at the security gates, but there will be plenty of photo opportunities during the tour.
Coming up here on the right, and that is just like the one. Alan Shepard made a 15-minute flight into space in.
Standing tall in front of KSC's badging station is the Mercury Redstone rocket. It represents NASA's earliest efforts to send humans into space. These Redstone rockets were formerly ballistic missiles provided to NASA by the U.S. Army. In October of 1958, NASA formally organized Project Mercury with a mission to investigate man's reaction to this new environment and safely recover the capsule and its pilot. Man rating for human spaceflight on what was previously a ballistic missile was no easy task. After several modifications and test flights, a Mercury capsule carrying Ham, a chimpanzee, was successfully launched and recovered on January 31st, 1961. Just months later, on May 5th, astronaut Alan Shepard launched on a Mercury Redstone rocket, becoming the first American in space.
Hi, I'm Janet Petro, and welcome to NASA's John F. Kennedy Space Center, where NASA astronauts have ventured forth on flights of exploration since the 1960s. And what an exciting time to visit our multi-user spaceport. Through our Commercial Crew program, we are sending astronauts to the International Space Station from American soil for the first time since the Space Shuttle program ended in 2011. We're continuing to launch new research experiments and supplies to the space station with our commercial resupply services and launching the most technologically advanced scientific instruments to date into space through our Launch Services program. This all culminates in our ultimate mission, the Artemis program, where NASA will return to the moon, this time with the first woman and first person of color, and continue on to Mars.
Calls it the VAB. It is one of the largest buildings in the world by volume, and is the place where NASA completes the final assembly of its rockets before launch. The sheer scale of this building is hard to grasp, even when you're right next to it.
Do you ever feel really small when you think about space? What about when you're standing next to a skyscraper or a really big bridge? Well, I feel about as small as an ant right now. I'm standing inside the vehicle assembly building trying to grasp how large it really is in here. It has 4 bays. Each bay has 2 large horizontal doors below it and 7 smaller vertically opening doors above it, tall enough to fit the world's largest rocket through. In fact, these are the largest doors in the world.
Construction of the VAB required 65,000 cubic yards of concrete, 45,000 steel beams, 1 million steel bolts amounting to almost 100,000 tons of steel. Notice the flag painted on the outside of the VAB? It's the size of a 21-story building. The blue section alone is the size of an NBA basketball court. Each star is 6 feet across, and each red and white stripe is wide enough for this bus to drive down. And the entire VAB? It's so huge that the Roman Colosseum would fit on the roof with room to spare for a parking lot. By volume, the VAB can fit 3.5 Empire State Buildings, and it would take 250 billion ping pong balls to fill it. It was built in the 1960s for the Apollo program. Every Saturn V rocket that sent humans to the moon was assembled right here. Every space shuttle mission also assembled within these same walls. After the space shuttle program, a major renovation to the inside of this building began to accommodate NASA's next generation of rockets, the Space Launch System, or SLS. Lockheed Martin has developed a capsule called Orion. that will sit atop the SLS rocket. This capsule is designed to facilitate human exploration of the moon and eventually Mars.
Take a look at the 4-story building with the slanted windows as we drive through this area. This is the Launch Control Center, where launch directors and their teams oversee every rocket that lifts off from KSC and give the final go or no-go. I'm inside the LCC with Charlie Blackwell Thompson, NASA's first female launch director. Now, Charlie, can you tell us a little bit more about what a launch director does?
Absolutely. The launch director's job during the planning phase is to ensure that you have everything in place that you need to safely and successfully launch the Artemis missions. That includes things like your requirements are set, your launch commit criteria are understood, your procedures are ready to go, and your team is trained. The folks that sit in this room on launch day, they have a tough job, and that's to determine if the flight and the ground systems are go or no go. And I depend on them to make those calls on launch day.
Yeah, makes sense. So I hear that you're going to be the launch director for the inaugural flight of SLS with Artemis 1. Can you tell us a little bit more about the mission of the Artemis program?
Well, the Artemis program, Artemis is actually named for the twin sister of Apollo. And so if you think about all that we did during the Apollo program, how amazing that was. So it seems so appropriate that as we return to the lunar surface, we return to the moon, that we go under the banner of Artemis, the twin sister of Apollo. And while there are similarities in our program, there are also differences. This time our trip to the moon will be on a brand new rocket known as the Space Launch System, or SLS, carrying the crews in the Orion spacecraft.
What is the goal or purpose of sending humans to the moon again?
Well, the moon is a treasure trove of science and discovery. And so there's so much to learn from the moon. We're still learning from what the...
Here on the left, there's the VAB, the vehicle assembly building. It is 129 million cubic feet. At the time it was built, it was the largest in the world, and by volume, not height. To give you an idea how big the building is, look at that flag. That flag's 209 feet tall, 110 feet wide. Each star 6 foot wide. Each stripe 8.5. The blue background, size of a regulation NBA basketball court.
We're inside the VAB at level 26, 274 feet up. And I can see behind us, right over to the right, the newly added crew access arm attached to this mobile launcher. I want everyone here to meet Cliff Lanham, the mobile launcher project manager. Cliff, can you explain the significance of adding that access arm?
Sure. The crew access arm is one of the last major modifications to the mobile launcher in preparation for SLS and Orion. It basically will be the very last place on Earth that the crew will be before they're in the spacecraft and headed to space. Now, the White Room provides a contamination-free environment up next to the spacecraft, and as you suspect, it's white. It's the White Room.
Makes sense. Now, how does the mobile launcher support the SLS rocket?
The mobile launcher provides fuel and power to the SLS and Orion. It's actually the stacking platform for the rocket. So the platform next to this 380-foot tower that the rocket is actually built next to, and then the umbilical arms attached to it to provide that fuel and power.
Wow. And so does the mobile launcher actually go all the way to the launch pad with the rocket?
It does. And the crawler transporter comes in, picks up the mobile launcher with the rocket, transports that entire thing out to the pad in preparation for the launch.
Wow. Oh, that is very impressive.
It is. And I hope everyone here today has a great time at Kennedy Space Center. Enjoy all the great exhibits, and come back soon.
NASA is known for dreaming big, and big dreams require big equipment. I'm standing next to the Crawler Transporter, the largest self-powered land vehicle in the world. It was originally built in 1965 for the Apollo program and has since been updated to accommodate the space shuttle and now NASA's SLS rocket. Weighing in at 6 million pounds and capable of lifting and hauling 18 million pounds, the Crawler is an engineering marvel, even without a rocket sitting on top of it. This thing has 2,750 horsepower V16 diesel engines that can carry the Crawler up to a top speed of, wait for it, 1 mile per hour while carrying a rocket. Keep an eye out for the Crawler as we approach this area. And remember, we are visiting a working spaceport, so while the Crawler may not stay in one area for very long, it's bound to be out here somewhere. Now, let me introduce you to my friend, John Giles, the Crawler project manager.
I'm standing in front of Crawler Transporter number 2 at Kennedy Space Center. Crawler Transporter number 2 will be used for the SLS program to take the launch vehicle back and forth to the pad. We will begin.
Okay, here on the left is one of our Crawler transporters. They travel less than a mile an hour, and for every 32 feet, they burn a gallon of fuel. That's a hybrid. They were built in the 60s. They have 8 tracks. Each track has 57 cleats. Each cleat weighs 2,000 pounds.
That's about 4 feet thick and compressed to hold the weight of the Crawler and the mobile launcher. And then below that is some hydraulically compacted sand that can support all the weight. And then once we're there, we'll drop it all off. And then a few days later, there'll be a launch. We'll come back, we'll pick the mobile launcher up, and we'll bring it back to the VAB to start the process all over again.
With 50 years and some 3,000 kilometers or 2,000 miles on the clock, NASA expects the Crawlers to be in operation for at least another 3 decades. How cool is that? The latest refurbishment is complete and preparation is well underway for the first SLS mission. The Crawler will...
Coming up on the right are alligator holes. Sometimes we have alligators, manatees, dolphins. Let's see what we have this morning. We have water.
But why, some say, the moon? Why choose this as our goal? And they may well ask, why climb the highest mountain? Why, 35 years ago, fly the Atlantic? Why does Rice play Texas? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
When President John F. Kennedy made this speech in 1962, he set in motion an era of discovery that would change humankind forever. 7 years after he spoke these ambitious words, the world watched as Neil Armstrong and Buzz Aldrin became the first people to walk on the moon. The achievements of the men and women who worked on the space program in these early decades of NASA helped propel the technology we use every day. NASA and the thriving private space industry at Kennedy Space Center today are the living legacy of their story. As we arrive at the Apollo Saturn V Center to learn more about that historic era, get ready to step back into a time when NASA had everything to prove to a nation focused on one goal: to be the first country to land a person on the moon.